Hey guys, this is Kyle here today, and we'll be talking about MCP and Cursor and how we're able to automate and pull in data from our Jira and Confluence and our Atlassian enterprise tech stack. So we're going to be walking through how we built it with Cursor in under an hour, the repo that we used to set up our MCP server, and how we never left Cursor to accomplish all these tasks and see how that can make a difference for software engineers. We'll be showing you the Jira board, the Trademark Fetch, which is the project that we're working on, as well as our Confluence knowledge base. Our Jira board has 4 tasks for us today. The first one, which we're going to be focusing on, is called Cam1. This is called Trademark Fetch. So we need to do some UI. You can see the description. This is all within the website. Let's move on to Confluence. In our Confluence content page, we have directory nodes, meeting nodes, how to get the local pages running. Some documents that could be useful. This is more for demonstration purposes. So the knowledge base is not fully loaded, as well as our Jira board. Our trademark fetch page here, you can see it's like trademark details. We're going to be focusing on here is the Adidas logo. And we're going to make it 300% larger and 90 degrees turned, which is labeled in our hero task. So now that we have those 3 resources that we're going to use in Cursor, we're going to quickly run over to Supersets GitHub MCP Environment server that uses Confluence and Jira and show some love, because this is a great repository that has done a really good job to quickly build in Confluence and Jira features by simply using an API token and running a Docker container instance. So there are different use cases that I see showing as well: Jira updates, Confluence search, issue filtering, and concentration management. Some simple use cases that really been built out and thought out by Supersets. Now that we have all the information we need to understand what's going on for the project, we can now look at our Cursor environments, as well as how we kind of set up quickly our MCP Cursor. In order to get to what we have this folder called MCP.Atlassian, which was that repository I showed you earlier. In the environments, all you need is an API token issued by Atlassian. A quick tip is to use the one without a scope. That way, there's no need to define what access you guys need. It gives you access to mostly everything. We can look at the environment example. And all I filled out were these 2 for Confluence and Jira. My domain was Trandev. I put my email in as well as my token. It needs 2 separate API tokens, and you can typically get it running. Once you have your tokens created, you can go into your terminal or ask Cursor. I just asked Cursor to deploy this into a Docker container for me, which is shown here. And you see how it is running. It's only used whenever it's needed. We can see that it's working if we go to our Cursor settings under MCP, and we'll see our MCP servers. This Jira one above is the one referencing this repository I was using. It worked okay, but it was not good at handling transitions or status changes. So I decided it's best to use Supersets, which had Confluence and Jira built in, as well as having the transitions and updating statuses works a lot better. So you can see that our server link is specified here in our MCP JSON file. The port we're running on is 9000. Once I specified that, it's now able to connect to Docker running locally. If I were to stop this Docker container, my MCP says it's turned red, so there's no more connection. It tells you there's an issue connecting to this port. I'm not able to use Confluence or the MCP calls anymore. I can quickly run this back up, and you guys can see how it'll turn to green once this is running, and I refresh. Now it's ready to go. Let's start a new chat history and focus on trademark container, because that seems like that's where the meat of it's gonna happen anyways. It doesn't matter if you guys really want to. GPT-4, I tried to use Cursor Small to save on fast requests. It did not work. It does not have the agentic capabilities that MCP server calls are going to be used fast. Keep in mind that you only have 500 if you guys are the hobbyist users, which is $20 a month, or the same as business users at $40 a month. So GPT 4.1 is, I chose it for this use case because I believe MCP is more direction based. MCP is making calls, and 4.1 excels in following directions. 3.7 is great for thinking and reasoning and building out plans, as well as Gemini 2.5 Pro. Recently, we've gotten access to the preview model, if you guys want to put it that way. It's great at thinking and reasoning and brainstorming. It is a lot of text and context to account for. 4.1 is great for following tasks and getting straight to the point, which is great for our MCP use case. So I'm going to stick with 3.1 and use agentic capabilities. I'll make this full screen so everyone can see our trademark container. Since the focus is on this chat, I'll make that large. How we prompt it is we use natural languages or specific commands provided under Cursor settings. It's converting the LLM natural language into one of these commands. How to get started on my day is say, what is my first task for today? What is my first Jira task? I need to say, connect to Jira. Now it calls an MCP tool. I can run tool. And now it lets me say, hey, priorities. It says that there are 4 tasks. Here's one with all the different information needed. So now I have trademark needs to be bigger, rotate 9 degrees. And this is the bare bones of what is provided for me. I can say, what are the comments and description. If I want more details, that's just the title, what is created, and what's the priority. I want to get more information from my Jira task. By using just common phrases in common English, is not able to call all these MCP tools, Jira or Confluence, and see here. And you can see the description, users are losing focus, make it 300% bigger. There's also a screenshot possibly for me to check out. Some comments I left saying it's 300% too big, is this going to look funny? I'm just here to do my job. I see that it's 300%. Now let's jump into Confluence and see what possible pages, documentations, or files are useful for me to get this job done. So I will say, check my Confluence for anything trademark fronts related. So now following that Jira task, we're saying, hey, anything related to trademark, the front end, it creates an MCP command saying there's only 5 maximum pages that can list out. So we can see that there is instructions on how to get local instances running. There's one for directory nodes. Fronts is like the folder or parent page for all these different resources, as well as some meeting notes. So for me, I would say, hey, show me the entire page or the directory. Because maybe there's some certain files or screens in this code base here under trademark front that could be useful to me. So now it's going to take a little bit of time to list out the entire flow and all the different pages, purpose, key components, features. This was created to quickly reference every time there needs to be a new feature. What page or screen do we have to jump into to get things done? This is not really necessary with Cursor because it has code-based indexing, which allows Cursor to quickly reference the right file. But for my use case, I want to see every single file and directory. I would say list it out. Let's say this is all too much, and I want to also look at the meeting notes. So give me a summary of the meeting notes and this file of directory. All right, so now it gets the pages it needs using MCP calls, and now it's able to get trademark directory notes and meeting notes from last week. So now I can see that it quickly summarized trademark front directory notes and meeting notes from the sprint I had last week. Great. So now I have information on the directory and meeting notes. So let's try to code and build things out. Look back to our trademark container. I'm not feeding in trademark container context, but now let's ask it to use information from our Jira and Confluence to write the right code and run it for us. Using our Jira task, builds to the trademark container and use any Confluence documents needed to accomplish the test. Using my Jira task, code the trademark container, use any Confluence documents needed to accomplish the task to spec. So now I can send that request to Cursor, and now it has all the information for my Jira task and Confluence. So now it's going to quickly search my code base for a trademark container. So it knows that it already has, this container there. The requirements is saying it needs to be bigger, rotate 9 degrees, and it creates an implementation plan as well as updating the trademark container as needed. Now it's reading the trademark containers from lines 1 to 200 and 501 to 700. So now it's saying, hey, we've done your task. So this is the code that's provided. I have to make sure that it looks right. I can see that it is, so with this change to 300%, rotate 9 degrees, and, whatever class name that it needs to update. As, it looks like it's justifying the center now. So it looks good. I'll say, hey, those 2 changes are now good for me. I'm a new coder. I don't know how to run the local trademark to see it. I would say run it locally so I can see the changes. If we go here, we'll bring back our screenshot of Trademark Fetch. Side by side, let us examine the changes of what's provided. So it's saying that I need to go into the trademark front repository or folder and run npm dev. And it starts it up at localhost 3000. Just like that, it was able to make the change, call Confluence, as well as the Jira task. Now I can check if the changes are correct. I'll open up my localhost 3000. I'll copy this trademark so that we can see the side-by-side comparisons of what was done and what was not done. You can see how ridiculous this Adidas logo looks. This is not a real code change. We're not doing this for Trademark Fetch. Don't worry. It's not going to look that fun. TLS by popular demand. By allowing me to connect to Jira and Confluence, I'm able to make the changes in Vibe code entirely end-to-end without touching lines of code, looking at my and Confluence. I could have done everything within my Cursor environment and get this logo and mark rotated. I'm going to end this task. The changes are good. I verified it with my own eyes. I could say, hey, change the Jira task to done. So what I'm going to do now is close the ticket or task that I was assigned this morning. It's going to understand, hey, this is what it needs. What's the Jira tickets transition key in order to change to done, which in this case is called 31. And now it's able to change to mark as done. If we check our Jira board, it says marked as done. I didn't touch anything. You guys saw that on camera. This is all done within MCP and Jira. Now you have seen a great enterprise use case on how to connect Jira and Confluence into our Cursor using MCP. By simply having a local Docker container running at port 9000, we're able to connect many different parts of our workflow all into Cursor. The next step is combining our deployment plan with GitHub Actions, connecting it to AWS. That way we can monitor the deployments, integrations, and seeing if there are any issues that we could pull back using more MCP and updating the code as we grow. This code generation now is so powerful and so strong. We believe that integrating into systems is where human intervention needs to come into play. Our goal is to automate as much of the flow as possible all the way into the deployment cycle. See you in the next video as I focus on connecting GitHub and AWS. Subscribe to the channel if you believe this was useful. I had a lot of fun building this, and I've demoed it to a lot of different companies. It's a great way to show how AI, Cursor, and MCP is making a difference in our current environment. Thank you guys, and I'll see you guys at the next one.